Today we will talk about friction. What is friction? If you take one body A and you make it slide over another body B by applying some force, you will say it doesn't move very easily. There is some effort required before it starts moving. Why does it happen like that? It is because the surface of A and surface of B are not very smooth. I'm just trying to magnify it. Let's say this is surface of A and this is surface of B. When A is trying to slide over B, the irregularity in the surfaces offers some resistance in the movement. And this causes an opposite force, which is called friction. Friction is a force which is trying to avoid or resist moving of a body, sliding of a body against the other one. So the friction always acts opposite to motion of the body, of the sliding body. Okay. Now we have seen if you take a very heavy sack or drum lying on the ground, if you try to move it, it doesn't move for a while. And if you keep increasing your force more and more, then it starts moving. Now what happens till such time as you are applying the force, but it is not moving? Does it mean the friction is not coming into picture? No, it is coming into picture. So what happens? Let's define some term, then we understand. First term is static friction. Static friction is a friction which comes into play till such time as the body does not start sliding. Let us say if you apply 30 newtons force, doesn't move. You increase it to 35, doesn't move. Only when you apply more than 40, it moves. Now what happens is, so long as your force is less than this force, it is not moving, but the friction is still acting. This is your applied force. This is friction. And since it is not moving, but you are applying the force, which means that friction is increasing, is keeping pace with the force that you applied. So an interesting thing comes up, and which is that during static friction is equal to applied force. So as you keep increasing applied force, friction also keeps increasing till such time as body starts to move. Right? So we can say that static friction is proportional to force applied, and it has a maximum value which we equate as mu is the coefficient of static friction and n is the normal reaction of the body. This is the maximum it can go to, not beyond that. Now you must have seen, once your sack or a drum starts moving, then it becomes very easy to move it. Maybe if you reduce your force from this value to some lower value, the drum keeps moving happily, no problems. So what does it mean? Once the body starts moving, there's another, the role of static friction is no more there. There's another force that comes into picture, another friction that comes into picture, which is called dynamic or kinetic friction. As we have seen that dynamic friction will always be less than static friction. And mathematically, we write kinetic friction as Fk equal to mu k. No. This is the kinetic friction. This is the coefficient. And this is the normal force. In a lab, we can find the static friction by doing experiment like this. We take an inclined plane, which is inclined at theta. We put a body here and keep increasing this angle till such time as this body starts to move, slide. Now in this case, what happens is, our inclined plane, see, this is mass, this mass m gives rise to a vertical force, which we can resolve in two directions. This is theta, so this will also be theta. This becomes mg sine theta, and this component becomes mg cos theta. Since there is no movement in this direction, there is an opposing force called the normal force. Now, if we equate the components, what we see is that normal should be equal to mg cos theta. Second is the force which is making it slide down should be equal to, it was just equal to the frictional force which was generated, right? So we can say this force was the maximum force, so we call it F max. If we divide this by this, what we get is tan theta is equal to F max by m. And we've seen earlier that F max is equal to, so our tan theta becomes so mu static is tan theta. This is one way of measuring static friction. Another way is you take a plane surface, you put one body here, attached to a pulley, and to pulley you attach another weight. Now you keep increasing W2 till such time as this weight starts to move in this direction. In such case, what happens is, since the body is moving in this direction, our frictional force will be acting in this direction. And since it just starts to move, this frictional force is the maximum frictional force that you experience, right? And we know that F max is equal to mu n, where n will be, this weight will be pressing the surface downwards, and as a result of which it will be pushing it backwards, upwards, and its value will be exactly same as W1 in terms of weight, kg weight. So F max is W mu or mu static becomes F max by n. And we knew that F max was nothing but the maximum weight or the minimum weight that was required to move it to get to maximum F max. So this becomes W2, and normal is because of our weight W1. So static friction can be obtained by this could be same as M2 by M1, whichever way you take it. There's a difference between these two, just a difference of G each term. Now, we've seen that whether you go for inclined method, inclined plane, or this method, they will give you only static friction.